Good morning everyone. Jai Hind to all. This is Dr. Shivani Agarwal. Today my presentation topic is disk scheduling. So let's start with the topic. So basically what is disk scheduling basically? So we just give with the diagram with what is the look of the disk. Basically the hard disk divided into the number of platers. These are the number of platers, and each plater divided into the number of tracks. These are the tracks. So plater is like a disk. Disk is a plate, a one plate known as a plater. So there are the multiple platers in a disk. So this is the formation or the foundation of disk, that these platers are divided into the number of tracks, and each track, there are number of tracks in a disk. Each disk have a number of tracks. It represented by the track, that is T, and each track divide into the number of sectors. So these blue symbols represent as a sectors. This S denote the sectors. So the data is stored in number of sectors. Suppose we want to search a data in a particular sector, so we know about the address of that particular sector. So how we just relate, or how we just find that particular address of that particular sector. So when we find the address of that sector, so that address we found by using the spindle and the read write head. So this is a spindle. Spindle always move or rotate with the anti-clockwise rotation, and these read write head move with the back and forth rotation. So when we want to find the address of any track or any sector, so this read and write head just move with the back and forth portion, and this spindle move the clockwise rotation. So basically this is the complete working of the disk. Now how we have find the seek time of this particular disk, that what time or how much time it required to find out the particular sector of a track. So this particular time known as the seek time. Seek time means how much time you just go with this particular sector. So there are multiple algorithms are present of the disk scheduling. Those are used for find out the seek times. So just move with the previous slide. This is the mass storage structure of the disk. That magnetic disks provide the bulk of the storage, secondary storage of the modern computers. Those are represented in the plater form, and these surface platers divide into the number of tracks, and each track divided into the number of sectors for storing the data. Now the very important points are there, that drive rotate 60 to 200 times per second. Just a minute. Yes, drive rotates 60 to 200 times per second. This is the important point. And the transfer rate, how much time it will take for transferring the data between the drive and the computer. So this is the transfer rate. Now the positioning time. Positioning means random access time. So it is a time to move the disk arm to desired the cylinder. Which cylinder you want, that is the seek time. How much time you just find out that particular sector of the track. This is the positioning time. And time desired for sector rotation of the disk head. This is the rotational latency. So these are some important points that we have to discuss in the mass storage with that particular diagram. Now the head crash. What is head crash? Basically head crash means it gives the result from the disk head making while the disk surface. So this is the head crash. So these are some basic important points of the disk storage, or the overview of the mass storage structure of the disk. So this is the basic diagram. What is the working of the spindle, what is the read write head, what is the basic working of the spindle and the read write head, what is track, what is sector, and what is the plater. So this is the complete working structure of the disk. Now we have to move with the disk scheduling. what is basically the disk scheduling and how we have to do the disk scheduling with the different number of algorithms. So basically, disk scheduling means we want the seek time. We want to minimize the seek time, or we want to find the data from the disk with a minimum time. So these algorithms are used for finding the best seek time mechanism. So basically, the operating system tries to use the hardware efficiency for finding the better solution. So for the disk drivers, we want that access time is fastest, disk bandwidth is used. So how much seek time we required for finding the actual position of the disk, and how much the rotational latency are used for that particular purpose. So basically, access time has two major components, that is the seek time and the rotational latency. Seek time means it is a time to move the heads to the cylindrical containing the disk sector, which sector you want, and how much time it required to fetch out that particular sector that you want, that is a seek time. And what is the rotational latency? Rotational latency means the additional time waiting to rotate the desired sector to the disk head. How much rotational latency required for seeking that particular track or that particular sector that you want. But our main purpose is to minimize the seek time. How much time required to find the data from that particular sector of a track or of a surface. So this is the basic of the disk scheduling. Now the disk bandwidth means it is a total number of bytes transfer from the disk to the computer. So this is the disk bandwidth. So these are the basic important points of the disk scheduling. Now we move on with the disk scheduling algorithm. So the first algorithm of the disk scheduling is FCFS. So FCFS means first come first serve. So in this particular algorithm, we just have the number of disks that we want, or we want to read those number of disks. So these disk numbers are in the queue form, and we head start point is the 53. So in this particular diagram, the head movement is 640 cylinders. How we calculate the 640 cylinders, I just show in this particular slide. But first, how we have to move from the one location to the another location by using the algorithm of the FCFS. So because the algorithm named is FCFS, so it just move on from one by one. So we start from 53 because the head starts from the 53. The position of the head begins with the time 53. Now from 53, just the next number is 98. So we don't think anything more. We just move on from 53 to 98. Then 183. So we move from 98 to 183. Then 37. According to the ordering, we have just moved from one place to the another place for reading that particular this number. So this is 183 to 37, then 37 to 122, then 122 to 14, then 14 to 124. Same, this is the first come first serve mechanism. So which number is in the queues, then we have to move from one by one, and we start from the head count is 53. So this is a basic diagram of the FCFS, that this is a searching diagram of the numbers those are present in the queue. We just move from one by one. So how much total time or how much seek time seek time involves in this particular algorithm? So these are the 640 cylinders are required for the total head movement. So how we calculate this? Basically, first we have to calculate from, because this is a one direction from this to this point. So we start from 183. So 183 minus 53. Now again we have to just minus from highest to lowest. So again 183 minus 37. The second movement is this, 183 minus 37. The third movement is from these are the another one. So this is 122 minus 37, and now begin from 122 minus 14, highest to lowest. We always less from highest to lowest. Then again the second is 124. So 124 minus 14, then 124 minus 65. This is 124 minus 65, and then 65 minus 77. Sorry, 67 minus 65. So these are the total numbers. Those are calculated as 640 cylinders. So the calculation of these particular numbers, when we add all these, so the total of these numbers are 640. So this is the FCFS algorithm, and total number of head count of this particular algorithm is 640. So we just calculate the numbers from that, and this is the basic formula of for counting the head movement. Now the second algorithm is shortest seek time first. This is SSTF. What is basically SSTF? SSTF means this is same as the SRTF. Select SRTF algorithm is from the disk scheduling algorithm, but this is the scheduling algorithm, but this is the disk scheduling algorithm. This is the SSTF. This is the shortest seek time first. So in this algorithm, we just find the minimum seek time. So which position you have to give in, then you have to just find the minimum seek time from the all of the queue, all of the data present in the queue. So we just find the minimum seek time from the current head position. Then yes, this is right on this. This is the same formation of the SGF scheduling algorithm, and it may cause starvation of some request. Illustration show that total head movement of 236 cylinder in this particular example only. This is not for all the questions. This is belonging with this particular example only. So these total head count cylinders, head movement cylinders are the 236. So just how we have to do the SSTF algorithm and how we start. So we start with the head start position is 53. So in this algorithm, we just find the total numbers are 98, 183 that we want to search from the disk. But in this algorithm, we just find the minimum number from the head start. So 98 just minus from 98 to 53, 180 to 53, 37 to 53. But we just search that which is the best or the minimum seek time from all the sequences are present here. So the minimum number of the seek time is 65, because 65 minus 53 is lesser than the other numbers. So the minimum distance from the head start point 53 is minimum is from the 65. So we start from 65, then the current position is 65 right now. Now from the 65, which one is the minimum distance? So this is the number 67 is the minimum from the 65. So we just move from 65 to 67. Then from 67, which one is lowest? Now 37. So it is 37 is lowest than others. Then 37 to 14. Then 14 to 98. Then 98 to 122. Then 122 to 124. And the last is 183. So this is the basic head movement of the SSTF algorithm, because it's just based of the minimum distance algorithm. So we start with the head count 53 and we just find which number is the minimum distance number. So just we have to move that particular location from that particular head start count. So from this algorithm, how we calculate the seek time or the head movement, total head movement. So the same process that we use in the FCFS. So it is 65 minus 53, highest to lowest. Now 67 minus 65. Now the next, there is the second method basically. The first method is 67 minus 53, then 67 minus 14, then 122 minus 14. But this process is also used for calculating the total head count. So this is 67 minus 65. Then we have to move just 67 minus 37. Now 37 minus 14. Now 98 minus 14. Now 122 minus 98. Then 124. Each and every movement we have just minus with the other number. So we have to calculate the total head movement. So it is 124 minus 22, and the last is 183 minus 124. So these all the numbers just we have to calculate for calculating the total head movement by using the SSTF algorithm. So SSTF algorithm is used for the minimum distance from the head start. So this is the second algorithm. Now the third is the scan. Scan algorithm start at one end of the disc and moves towards to the other hand. In the scan algorithm, we just head movement is reversed when it get to the other end of the disc, and then the service continues. And this algorithm known as the elevator algorithm. This is a very important point, that this algorithm also known as the elevator algorithm. Sometimes in the examination, the scan algorithm named called as the elevator algorithm. So you just keep in your mind that the scan algorithm is also known as the elevator algorithm. In this algorithm, in this scan algorithm, one more important point that you have to just keep in your mind, that we if we want to move to the towards direction, that direction is the decreasing direction. So we just move with the 0 till end we have moved. If we start from the reverse direction, the current position is 53 and we have just downward from the 53, then we just continue with the 0, continue till the 0. If we move from the upward direction from the 53, then we just move from the till 199. So if we movement from the downward, then we move till 0. If we move to the upward, then we move till 199, the end of the position of this particular series. So these are the total numbering, because the range of that particular scanning or disc scheduling algorithm has the total number of tracks are 0 to 199. So this is the particular view of the scan algorithm. This is always kept in our mind. So we start with the 53 because head start from the 53. We just move 53 to 37, 37 to 14, 14 to till 0. 0 is not present in the queue, but we move till 0 because this is scan. We just scan that there is no other track required to read. So we have just moved with the starting position till the starting position. And now from the starting position 0, we just move with the other heads that required for the reading. So this is for 65, then 67, then 122, then 124, and then 183. Now the end we just till the highest number of the queue, but not end of the queue number, that is 199. If we just use the downward position, so we till goes to till 0, and when we use the upward position from the head count, start head count number, so we just going with the last number of the complete scenario. So this is the scan algorithm, and in the same we just calculate the head counts from there are two methods that I already explained. First is in FCF, second is in SSTF. So we just calculate the total head movement. So there are two methods. First is 53 minus 0. First is 53 minus 0 plus 65 minus 0 plus 67 minus 65 plus there is a movement from 122 minus 67 plus another movement 124 minus 122 plus, and the last seek position is 183 minus 124. So first method is this, and the second method is what? 65 minus 53 minus 37, 37 minus 14, 14 minus 0. These all are added with that. And next is 65 minus 0, 67 minus 65, 98 minus 67, 122 minus 98, 124 minus 22, and the last is 183 minus 122. 4. These are the two methods for calculating the total head movement. So these are the scan algorithm. Now the C scan. It is a more uniform waiting time than the scan. In this, the head moves from one end of the disc to the another, servicing request one after another. When it reaches another end, it is immediately returned back to the beginning of the disc and then start the scanning. So this is the C scan algorithm. This is the round up algorithm. So just see in the graph. In this graph, we start with the head count of 53 and we just move 53 to 65, then 65 to 67, then 67 to 98 according to the sequence. But the main point of the C scan algorithm is that because we start with the upward direction, so we just go with the upward direction with 199, and then this is the last point. That 199 is the last point, and that is not mentioned in the queue. But we move till 199, and then we move from last to end. Then we movement start for the request queue with the number after the 0. Then again we just move from 0 to 14, then 30, 34. So we just move with the till end point, and then we go to the start point. Then again we search according to the queue. So this is the C scan algorithm. Is just go with the end movement, then it go to the towards till end. Till end means till the starting point, and then we just scan the request those we require as a queue. So this is the total head movement count in this C scan algorithm. Is calculating is same as the scan algorithm. So we just start with 65 minus 53, 67 minus 65, 98 minus 67, 122 minus 98, 124 minus 22, 183 minus 24, 199 minus 83, and 199 minus 0, then 14 minus 0 and 37 minus 14. These all the subtraction we have to add, and then we have to find the total head movement. Now the look algorithm. Look algorithm only goes as far as the last request in the each direction and then reverse the direction immediately without going all the way to the till end of the disc. So this is the basic of the look algorithm. We start with 53 and we just move till the request demands. So the request demands is 176. Then we just searching which number that not go till end is 0, but it just reverse the direction, and in the reverse direction we just search which number we required. So we don't go because that in the C look algorithm it creates the overhead because we goes to the end point, but we don't demand the 199 number in the queue, but we go to the end point and then we go to the next direction or the starting point direction till 0, then we start the searching with the reverse direction, but this creates the overhead. But C look algorithm just go till the number and then just move the searching from the another number. So this is look. Now the C look, it is a version of C scan and it only goes as far as the last request in each direction and then reverse directly without going all the way to the end of the disc because it creates the overhead. So C look don't create the overheads for scanning. So it just goes with the maximum number. It just scan the maximum number from starting head count number. This is the end of the number is 183 because it requires 183 is the last number in this particular queue, and we want to search that last number in this particular sequencing of the head count. So because this is the 183 is the last number, and then we reverse till which number? Till this reverse is not till 0, not the starting point. It just reverse till the minimum number of the searching of the queue, that is the 14 is the minimum number in this particular scanning queue. So we just move till 14 only. So this not create the overhead. So it becomes a good algorithm, and CLOOK is a very good algorithm for the scheduling or for calculating the minimum head count, head movement. So it is the bestest because it is the minimum seek time, and the demand of ourselves is also minimum seek time. So this is the good algorithm. So thank you for this lecture.